Hi guys, welcome you all. And today we are going to discuss hardware security in a VLSI. How the hardware system or a hardware security which will be integrated in a VLSI integrated circuit integrated circuits. And next, introduction to the hardware security in VLSI. Here in the VLSI we are going to use the small chips. The small chips will be integrated with millions of transistors, resistors, the capacitors, that millions of transistors which will be integrated on the single chip only, and for them we are going to give a security. Then see, a lot of security threats we are going to affect for the single chip. If once the single chip is affected from the threats, security threats, it will be going to demolish all the thing. Here it involves implementing secure design methodologies to safeguard sensitive data. What is the sensitive data which will be integrated, which will be inserted in a single chip? And intellectual properties. Intellectual properties according to the companies. And here by incorporating security features and hardware levels, VLSI chips and sets various forms of attacking such as side channels, analyzing and observing engineers, and threats to VLSI hardware security. And we can found some images at the right side. And common security attacks in the OSI layer models. Here OSI, we know that operating system interface, layers, application, presentation. See, first initially we have a physical layer which will takes only the frames as an input. Next it will enter into the data link which will allows frames. The number of the bits are converted into the frames. The number of bits. That number of frames which will be converted into a packet. See, in the data link we are going to use a MAC address. In the network layer we are going to use a IP address. The packets are used in the network layer. Packets are need to transfer one late. See here forwarding the packet one place to another place, which will be done in the network layer. This transport, in the transport we have ports. We are using the ports to transfer some payload from the data. Next we have session layer. Next presentation layer, and application layer. Here the application, the transport layer. These are all including in a software, and these three are including in a hardware. And for them we need to give a security. And the security measures in VLSI design. So encryption technologies such as AES and RSA can be used for protecting sensitive data storage stored and proceeded within a VLSI chips. And we have here hardware obfuscations methods like a logic locking, and some of the methods we have to we are integrating the chip, because we need to give a good security for the chip. Otherwise a lot of loss will become towards the company. And yeah, physical security mechanisms such as temper resistant packaging and sensors can detect and respond to the unauthorized physical access to the VLSI chip. And some of the designs we are going to occur through the, like a VLSI is nothing but a very large scale integration. For them definitely they need some security purposes, security methods through an appropriate way. Next, before coming to the conclusion, let me know what are the Main focuses on the security design in the VLSI. Next year, mainly the VLSI. For the VLSI, very large scale integration is a crucial aspect of our modern CR is a crucial aspect of modern electronics. I'm mainly focusing on protecting the integrated circuit SOCs like a system on chips from various security threats. And as the complexity and integrated design density of ICS integrated circuits increases, and so due to the potential vulnerabilities, here some key aspect we have to know. Some key aspects of hardware security in VLSI. Next one, see we have some of the key aspects in a VLSI hardware security, and one is design, like a design time security, and see design time security, it will focuses on a secure design practices, and another one is a security verification and validation, and another one we have manufacturing security. See, while the manufacturing, during the manufacturing we are going to, they are going to set some of the protocols, IP, like IP protection, some protecting the intellectual properties. Sorry, IP is the intellectual property, some of the protection throughout the IP intellectual properties, not a internet protocol. This is an intellectual property, and during that manufacturing process to prevent secure engineering and cloning and hardware trojans, detecting and mitigating malicious modifications. Next, runtime security we have, like a runtime security is like a slide channel attacks and fault ejection attacks. Some of the viruses will be ejected through the runtime security, and those are need to detect through the proper security, through the proper security way. We need to detect all the things, because otherwise the whole system getting into the damage, because a lot of money will be spent on one chip, because many transistors or millions of transistors or the resistors or the capacitor which are integrated on the single chip only. And this is so sensitive, not as sensitive, it will be a very it is very uh, impactable for the all the hardware and software systems. Next, technicals and strategies, we have to know some of them. Physical unclonable functions, secure boot, uh, trusted trusted execution environment, like a cryptograph hardware. Those are the, and those are technical and strategies, so we have to know them. And challenges, we have to, challenges are nothing but complexity and the cost. These are the challenges we have to face, and the scalability and emerging threats. These are the challenges. And next, come to the conclusion and the future directions. Hardware security in VLSI is a crucial aspect. We know that it is a crucial aspect towards the hardware system, and the future research directions including exploring emerging technologies such as quantum safe cryptography, hardware-based security primitives such as AI and AI drive threat detection for challenging VLSI hardware security. These are the future directions we have to focus on. And this is for the today's session. And until for the next video, bye. And keep supporting and do like my video.